In this video, we'll take a deep look into the finite state machine system of the enemy AI asset. We'll show how to extend, or even create an entire new FSM for a different type of NPC, a hostage. With a more practical approach, we'll focus on the creation of the states and actions, decisions and transitions of the FSM. Let's get started. We start with the scene that we have created in the previous video. Let's make some adjustments in the level design to make it more appropriated for the hostage scenario we are creating. Start by selecting the robot Kyle enemy and also its two waypoints. And now, drag it away from the covers. Now, grab the camera, the weapon, and also the player. And drag them away from the covers too. We will keep the covers in the path between the player and the enemies. We need a model to use as the avatar for the hostage. We'll use the default shadow model from the enemy AI package. Use the package manager to import the enemy AI or the third-person shooter bundle package. When the import dialog appears, click on None to deselect all the assets. Then, scroll down the window to find, under Examples, Models folder, the Char Shadow model. Select it and click on Import. Now, opening the Enemy AI, Examples Models folder, we drag the model somewhere near the player on the scene. Let's give a more appropriate name for it. We'll simply name it Hostage. Since we need to highlight it from the scene, let's make a custom material for it. Under Create, select Material. And name it Hostage. Then, pick a custom color for it. I will just use this existing orange here. Finally, drag the material to the hostage on the scene. Back to the hostage, we'll start configuring it. Let's start by the animator. We'll set the same animator controller as the enemy, since they will use the same animations. So, select the enemy animator. We need to add a navmesh agent to the hostage, so it can navigate in the scenario. Click on Add Component and select Navmesh Agent. We'll need to configure it. Start by setting the stopping distance as 0.5. Under Obstacle Avoidance, set the radius to 0.3, and finally the height to 1.8. Next, we need to add the state controller script that will control the finite state machine of the hostage. Click on Add Component and select State Controller. Now let's configure it. The first parameter, General Stats, refers to the type of NPC we are creating. Right now, we have just the enemy stats. We'll need to create a new one, specifically for the hostage NPC. Under the Project tab, right-click on the Assets folder and go to Create Enemy AI General Stats. Name it Hostage Stats. Now we'll configure it for the hostage. Under the General section, we may keep the default speeds, excepting the obstacle mask, where we must select the bound layer. Skipping to the cover mask parameter, we must select both the cover and the cover invisible layer. As a reference for the default values, we can refer to the existing enemy stats. Getting back to the hostage stats, the last parameter we need to set is the target mask. Since the hostage will be unarmed, not shooting anything, we may skip the shot mask. So, expand the target mask and select the enemy layer. We will be using the hostage senses to detect and avoid the enemy, so this is the targets we need to focus on. Now that we have configured the hostage stats, we can get back to the hostage and set the general stats parameter. So let's drag it here. Proceeding to the class stats, we have a similar situation, where we'll need to create a custom class stats for the hostage. Under the Assets folder, select Create Enemy AI Class Stats. As the hostage is an unarmed NPC, we'll name it Unarmed Stats. Okay, we can basically ignore all the parameters, since most of them refers to armed NPCs. Like the animation section, and also the shot section. As for the change cover chance parameter, we may keep it 0, since the hostage will not be changing covers in the same way an enemy does. Getting back to the hostage, we can drag the unarmed stats as the hostage's class stats parameter. We'll set the current state parameter later, when we will create the finite state machine for the hostage. We can select the remain state as the remain state parameter here. The next parameter is the aim target. We'll use the player as a reference for the hostage to follow. So, let's drag the player under the aim target parameter. We skip the patrol waypoints and bullets parameter, so let's go straight to the senses. Starting with the view radius, set it to 20. The hostage will use a much simpler sense to detect the enemies, that will ignore the field of view. So we can use the full sphere here. Set the view angle as the maximum value. Finally, for the perception radius, set it as 7. This parameter will be used by the hostage to know that he is near the player and can stop following him. It will also be used as a threshold to define how fast the hostage will follow the player. Now we'll start creating the first state of the hostage custom FSM. To create a new state, right-click on the Assets folder, go to Create Enemy AI, and select State. Name it Hostage Follow State. Under the State Parameters Setup, we start by setting the actions of the state. There will be only one action, which will be the follow action. We need to create a script for that will later be transformed into an asset. So, let's do it. Right-click on the Assets folder, select Create, and go to C# Script. Name it Hostage Follow Action. And double-click on it to open. With the script open for editing, we can erase all of its contents. We must inherit it from the action script. For that, we need to import the enemy AI namespace. As this class inherits from the action class, we'll need to override the two default methods. The first one is the onEnable action. We can erase its contents. And the second one is the act method. We can also erase the contents as well. Well, let's start coding the contents of our follow action. The first parameter we'll need is a reference to the player, so let's create it. Inside the onEnable action method, we'll set this reference. When we finish the FSM, this follow state will be called from cover state, when there is no detected menace for the hostage. So, we need to reset some parameters here, that will be set in future states we'll create. First, we need to reset the personal target for the hostage. Next, we must reset the current cover position for the hostage, since he will be leaving a cover spot. The last one is to reset the cover boolean, as we are changing from a cover to a standing position. We can do that by grabbing the animator controller reference. and then setting the boolean, which is the crouch in this case. With the onEnableAction method completed, we can proceed to the act method. In this action, the basic idea is to use the vector reference from the player to the hostage and also the hostage senses. We use both to define a projected position for the hostage to follow. With that projected position set, we can define it as the navigation target for the hostage's navmesh agent. That position will dynamically change as the player moves. This will ensure the hostage will follow the player even when moving. Eventually, the hostage will reach the near radius distance from the player and then stop. Back to the script, we start by getting the vector from the player to the hostage. This vector is given by the subtraction of two world positions. The hostage world position minus the player world position. Now, to get the projected position we want the hostage to target, we must use the near radius parameter. First, we must normalize the toHostage vector. Then, we can apply the proper length for it, given by the near radius value. Finally, we can set the navigation destination as this projected position. The destination world position is given by the player world position plus the toHostage projected vector. To make it possible the creation of an asset from this script, we must define a menu entry for it. We do this by creating a Create Asset menu annotation, and then setting the menu name parameter as the full path we want for it in the creation menu. With the hostage follow action concluded, we can get back to the editor. Now, we must create the action asset. Right-click in the Assets folder and select Create, Enemy AI, Actions, Hostage Follow. Remember to name it properly. Back to the hostage follow state, we must drag the newly created hostage follow action to the empty action slot. Okay, back to the hostage in the scene hierarchy, we must fill the current state parameter with a hostage follow state. Now, we can test our scene for the first time. Let's try it. As we move the player, we can notice the hostage following him and stopping at the near distance. However, there are some tweaks we can make to optimize its behavior. The first is the speed at which the hostage follows the player. The basic idea is to use the perception radius as a threshold. In case the hostage is outside this radius, the following speed will be faster. Otherwise, in case the hostage is within the radius, he will follow the player at a slower speed. Until this distance is the near radius, that is always half of the perception radius, and where the hostage stops. So, let's get back to the hostage follow action script. Basically, to perform this modification, we need to compare the magnitude of the toHostage vector before normalizing it. We do that right here. We starting by checking if the current vector magnitude is more than the perception radius. If so, we can apply the faster following speed, in this case, the evade speed. Otherwise, in case that the hostage is within the perception radius, we can apply the slower speed, the patrol speed. We can go back to Unity to check the results. we can observe now that, moving the player away from the hostage, the latter increases his speed. And we can confirm that he slows down when within the perception radius, while he still stops when reaching the near distance. Proceeding with the FSM creation, we will now add our first transition. So, let's get back to the hostage follow state. Change the transition size to 1. A transition is given by a decision that may return true or false. We can transition from this state up to 2 other states, given by the true or the false decision. In our case, we will be checking if the hostage is in danger, to look for protection, taking cover. So, we want to remain in the follow state, in case the decision returns false. We do that by selecting the Remain in State asset for the false state here. Now, we need to create the script that will generate the decision asset we will use. Under the Assets folder, select Create, C# script. Name it, Hostage Danger Decision. And open it for editing. We start again by erasing its contents. Then, we must import the enemy AI namespace. Now, change the class inheritance to the decision class. The only mandatory method we need to override is the decide method. We may erase its contents as well. To check for danger, we will use the hostage view sense. The decision base class provides a common function, named check targets in radius, that we can call for it. The needed parameters are the state controller, the radius to delimit the area, in this case the view radius. And the last one is a callback function that we will need to implement. We will create a private function named myHandleTargets. The parameters of this callback function are the state controller, a boolean that informs if there are targets detected, and a list of colliders of the detected targets. We can then fill the last parameter above with the callback function. Skipping to the contents of the myHandleTargets function, we first need to check if any of the detected targets is alive, meaning it is a menace in fact. Let's declare a Boolean variable here for that. Now, we will pass through all the detected targets, if any. We need to check for 2 conditions here. First, if the enemy is not dead. We can do that by checking the enemy health script dead property. Then, if the enemy is on the hostage site. For that, we'll create a function named EnemyOnSite. The parameters for this function are the state controller and the enemy position. Let's create that function. Remember to repeat its name and also to declare the receiving parameters. To perform the check, we'll first get the enemy position. Since the hostage will not look down to the enemy foot, that position must be above the ground. We can use the above cover height parameter here, that basically defines a visible position above any cover. We do a similar calculation to define the ray cast origin, that will start from the hostage position. Finally, we can define the direction of the cast, that is spatially given by the subtraction of the previous position vectors. Now we can return the cast result itself. Remember to add the exclamation point, since we will be checking for obstacles between the two positions. The parameters of the cast are the origin, the direction, the maximum length of the cast, and the obstacle layers. For that, specifically, we will consider the cover mask and also the obstacle mask. The basic idea here is, if the cast finds an obstacle, the enemy is not on sight. If not, the cast has a clear view, so the enemy is on hostage's sight. Back to the myHandleTargets function, inside the targets iteration section. As we have detected a target, and it is alive, and also on sight, we can confirm the danger situation. First, we must set the enemy alive boolean to true. Then, we must set the hostage's personal target to the enemy position. Since we have already detected a menace, we can break from the iteration. Finally, we can return the enemy alive boolean as the decision result. We must also return false here, in case there are no detected targets. We've almost finished the decision script. Now, we must add the Create Asset menu entry to enable the asset creation from this script. Remember to pass the menu name parameter as the full path in the menu for creating this decision asset. Let's get back to the Unity editor. In the Project tab, right-click on the Assets folder. Select Create, Enemy AI, Decisions, Hostage Danger. Give a proper name to it. Now, get back to the hostage follow state and drag the hostage danger decision to the decision parameter of the transition. Next, we need to create a new state for the FSM, where the hostage will look for cover to protect itself. Select Create, Enemy AI, State. Name it, Hostage Find Cover State. This state will perform just one action, and also, will have just one transition. The Find Cover action is already present in the Enemy AI package, so let's put it here. The decision we'll use also exists, and it is the reached point decision. For the false state, since we will not perform any transition, we must select the Remain in State asset. Finally, for the true state, we must create a new one. Go to the Assets folder and select Create, Enemy AI, State. You can name it, Hostage Take Cover State. This state will have one action, and it also exists in the package. Select the Take Cover action here. We'll add one transition for this state. The decision is the one we have created, the hostage danger decision. In this case, we reverse the outputs. For the true state, meaning the hostage is still in danger, we must remain in the cover state. So, select the Remain in State asset here. For the false state, we may select the first one we've created, the Hostage Follow state. Basically, when the hostage detects no danger, he can stop taking cover and go back to following the player. Now, let's get back to the Hostage Follow state. We can add the Hostage Find Cover state as the true state parameter we've left blank before. Then, in the Hostage Find Cover state, we must select the Hostage Take Cover state as the true state parameter. To conclude our FSM, we'll need to create one more transition. Go back to the Hostage Take Cover state. Set the transition size parameter to 2. This transition is related to the situation where the cover does not protect the hostage anymore. In that scenario, the hostage needs to exit its current position and find another cover. Since we'll create that new decision, let's clear this parameter here. For the true state parameter, meaning the cover protection has been blown, it needs to find another cover spot. So, we select the hostage find cover state here. As for the false state parameter, we select the remain in state, since the hostage may keep its current cover position. Now, let's focus on creating the new decision. Go to the Assets folder and select Create, C# script. I'll name it Hostage Blow Cover Decision. Open it for editing. In the script code, erase its current contents. Before changing the inheritance to the decision class, let's take a look on the hostage danger decision we've created. This decision behaves like the one we need to create, by checking the targets in the proximity, and then checking the direct site to them. The only difference for the new decision we are creating is the enemy on site method. In this new situation, we'll need a different point of view for the ray cast, since the hostage is down behind a cover. In fact, we can directly inherit from this class, modifying only the method that differs. For that, we start by changing the enemy on site method's signature to include the protected and virtual modifiers. Now, we get back to the hostage blow cover decision and change its inheritance to the hostage danger decision. We'll override the enemy on site method to create our custom point of view for the ray cast. We may erase its contents. First, we set the enemy's position to be slightly above the ground. Then we can get the direction of the cast, given by the enemy position minus the hostage position. Remember that the hostage is down on the cover, so there is no need to add a height to its position. Now, we can make the ray cast and grab its result. The parameters of the cast are the origin of the cast, the direction of the cast, the cast length, and the layer mask for it, given by the cover mask in addition to the obstacle mask. The reason we do not return the cast result directly is because we need to perform a modification in case the result is true. So, we do that. We need to invalidate the current hostage cover spot in order to look for another one. Then, we can return the cast result as the decision output. Remember to add the Create Asset menu entry for this script. And also pass the menu name parameter with the full path for the creation menu. Back to Unity. We create our decision by right-clicking with the mouse, then selecting Create, Enemy AI, Decisions, Hostage Blow Cover. Name the newly created decision. And drag it to the decision slot of the second transition in the hostage take cover state. Okay, before testing our scene, let's make some adjustments on the environment. First, we duplicate the existing covers to provide more protection options to the hostage. Put these ones on the left here. Duplicate again, and place these ones on the right side. Let's keep them somewhat aligned. Now, to make things more challenging, let's adjust the enemy's sense parameters. With the robot Kyle selected, set the view radius to 30, the view angle to 90 degrees, and the perception radius to 10. Before testing the scene, remember to bake a new nav mesh for the environment. Select the Navigation tab and click on the Bake button. And don't forget to save the scene. Alright, let's test it. First, we select the Maximize option here, then hit the Play button. As we can check again, the different following speeds, according to the distance, are working properly. Note that the hostage has already detected the enemy presence and looked for a cover. Let's interact with the enemy to create a scenario where we can validate the hostage blow cover situation. In a more stealthy approach, we'll evade the engage position and wait for the enemy to look for us. After 30 seconds of engaging the player's last seen position, the enemy enters the search state to investigate that position. We can see that the hostage detected the menace and is now looking for a new cover spot. Well, I believe today is not his lucky day. And here we go, let's finish the danger situation. Finally, we can see the hostage coming out of protection to return to the follow state. And this concludes our tutorial. As the objective here is to show how the enemy AI FSM works, note that the AI created in this example for the hostage is quite basic, with possible improvements to be included. A potential improvement is to add an extra evasion state when the hostage does not find valid protection to avoid looping through cover spots. With the enemy AI FSM system, you can create any kind of AI from scratch. Thanks for watching.